Hello everyone. We'll be talking about Euclid's postulates related to planes in this video. So planes is basically any flat surface. It can be your tabletop, right? We have a table. This top can itself be called a plane because it's a flat surface. It can also be a whiteboard. You can see that this surface is plane. So even this is a plane as this surface is flat, right? And not just that, even the screen that we are watching this, the screen I'm teaching this, if you take the whole screen, even that is a plane because it's a flat surface. Now let's try to formally define it. Again, in the same way that we constructed lines, we saw that it is a collection of points. Now let's see if we can see plane also as a collection of points. So let's take our whiteboard and let's take this as the plane area. Right? So this is our plane, and you can see even this is just a collection of points. Just a bunch of points very closely stacked together so that it seems like there's a plane, like there's no space in between because they're so closely stacked together, right? So even plane can be written as a set of points, and that's the postulate 3. Now let's talk more about planes. We saw that we need two distinct points to make a line. Now let's talk the same concept to planes. How many points do I need to make a plane? So let's start with 2 points. Can we make a plane just knowing 2 points on it? So let's take 1 point here and let's take another point here. And you saw earlier that when we're taking 2 points, we're getting only one straight line between them. So what we're trying to basically see is that if we have 2 points, can I find a unique plane, only one plane that it corresponds to? Okay. Now, in this blackboard is also a plane because it's a flat surface. And on this plane, I took 2 points. This is the first point, this is the second point. But as you can see, we can take a file and we can keep it right here like this. And you can see that these 2 points belong to both this file, which again is a plane, and this blackboard, which is also a plane. So these 2 points correspond to 2 planes, and it can be many planes passing through just these 2 points. So many planes can pass through these 2 points. So 2 points doesn't uniquely define a plane. I need the number of points that tells me that if I take these many points, it makes just one plane. It all corresponds to just one plane. So 2 points is not enough. Let's extend the idea. Let's see if we can do it with 3 points then. Again, we take a blackboard. We had our 2 points and we take a third point. And now let's try to put a file and see if we can see all 3 points corresponding to 2 different planes. And as you can see, I can paste the file here, but it's only covering these 2 points. I can also place the file here, but it's only covering these 2 points. So it shows that the only way that these 3 points correspond to a plane, and that would be this plane. There's no other plane that can happen, as we just saw. And if we connect the points, we get this shape, which is actually just a part of a bigger plane. As you can see, it is this plane. For convenience, we're taking this plane, but you can also argue that this plane is also itself a part of the whole screen, which is itself a plane. But considering in this planar area, this thing is just a part of this plane. And so 3 points are required to uniquely identify a plane. So that's what the postulate 4 says, that joining 3 points make a plane, and there exists only one unique plane formed by at least 3 points. But this definition is still not complete, because we sort of arrange the points in a way that they can make a plane. What about the different arrangements of points that can happen? Will all these 3 points give a plane? Or is there only some specific 3 points? And I'm saying at least 3 points. You can have 3, 4, 5, 6, any points. But it should be at least 3. So is there any more condition on the kind of points there should be? Let's think about it. So say we have 1 point here and we have another point here. And let's try different arrangements of the third point, which can give us a plane. So if we take a point here, then we can see that we have a plane, we have a flat surface. Next, if we see a point here, bit closer to it, we can still see that there is a plane formed. What about if I place the point just in the middle of it? Is there a plane formed? No, because this is what we talked about. These are the collinear points lying on the same line. So they do make a line, but they don't make a plane. What if I take it on the left side? It still makes a plane. So from this, we get that the 3 points are not just, it can be any 3 points. It should also be 3 non-collinear points, as in the points that are not lying on the same line. So let's edit our postulate 4 and let's write it properly. So not just this, we should have joining 3 non-collinear points makes a plane. There exists only one unique plane formed by at least 3 non-collinear points. And now let's look at the fifth and the last postulate, which is a combination of how lines, points and planes interact with each other. So if we take 2 points on this plane, we have 1 point here and another point here, and we know that these 2 points will give us a straight line. So by joining them, we can make a straight line. And if these 2 points are lying in the plane, then the line formed by joining them would also lie in the plane. And while you can see it, but you can also think of it in a way that a line, as we saw earlier in postulate 1, is just a collection of points. So this is just a collection of points. And because all of these points are between these 2 points, the originally 2 points that we took, and we can see that all of the points are lying on the plane. So the line formed, because a line is just a collection of points, would also lie on the plane. And that is what the fifth postulate says. It says that a line joining 2 points on a plane also lies inside the plane. And those are our 5 postulates of Euclid. And let's summarize it. So our Euclid's postulates say the first is line is a collection or sum of points. So first we start with defining what a line is. Then we talk how many points do I need to make a line, which says that there exists only one unique line between 2 points. I need 2 points to make a distinct line. Then we extend the idea to a plane. Again, we start by defining the plane. That plane is a set of points. And then we ask how many points do I need to make that plane. So at least 3 non-collinear points are needed to make a unique plane. That's the 4th postulate. And the 5th postulate is joining both the plane and line properties. So line joining 2 points in a plane lies inside the plane. So first 2 corresponds to a line and how many points are needed to make that line. The 3rd and 4th corresponds to plane and how many points are needed to make the plane. And the 5th postulate is an interaction of between plane and line. And that's all for today. Thank you.